Hey Ed, this is Shravan. This is my demo for the animation engine. So right off the bat, I'm going to start with the by converting both the animations that we have for the teddy and the humanoid, and this is a pretty straightforward batch file. So the clean all, just like I did with the viewer, the clean all gets rid of everything, the binary, the BLOs, and the SPOs. The clean me only gets rid of the binaries and the blows, so we can sort of reuse that. And so we're already done with the teddy anim. I'm just waiting for this thing to spit out the last of the humanoid anim files, and there we go. So I'm just gonna grab both of these and cut them and put them inside of the engine. Then, if everything works, I'm gonna kick off a build, and in the meantime, we can go over the overall architecture of the engine, which is basically I have everything in terms of animation controllers. So for a particular skeleton, for a particular model, I have this class called the animation controller. It manages a bunch of animation clips, and each clip manages a list of frame buckets where which basically at different key times make up all the frames of a single animation. And there, wow, that was great. So we'll get back to that. So you can see there's the Teddy. He's doing his idle animation. I can zoom out, and you can see there's a humanoid as well, who's apparently trying to get shot, I think. And the reason why I'm showing you this is, alright, so this was with looping turned off. If I hit the L key, they'll start up again, both of them. And if I go back to if I press the T and H, I can toggle between the cameras for the Teddy and the humanoid. So now if I hit the right arrow key, you can see that I've switched the animation. So now the Teddy and the humanoid, if I go back to the humanoid, now they've started doing different animations now. So there's that. Then I just slowed him down and reversed him. I just put him back forward. So I can also I can increase and decrease the speed using the up and down arrow keys. I can change the direction forward and reverse using F and R. And I can pause using the space key. I can play again using the tab key. So same for let me go back to the Teddy. So exact same thing for him too. Pause, start again, go back to the idle thing, do forward, do reverse, do forward, do reverse, and stuff like that. So that's the demo. We have the Teddy and we have the humanoid, and they both have two animations. The humanoid actually has three, but because my toggling is so fast, I actually skip the one that's in between, the punching one. I'll leave it as you as an exercise to sort of zero in on it. It's the one in the middle. The Teddy has the walk and the idle one. So okay, so I'll exit out of here, and let's see, how should we do this? I think the better thing to do is actually go to the converter first, because that is like hacky as shit. So in the converter, basically the two things that need to be exported are, one is the hierarchy, so the skeleton, and the other thing is actually all the animation data which comes in from keyframes. So I have these two structures over here that basically are also inside of my engine, so that we know in advance the data to expect. The hierarchy node is basically a single, a game. It's going to be the game object, so it's just going to be whatever name. The bone is what its index is, and then the index of its parent. So the way that we sort of end up doing this is inside of display animation. Come in here. Oh, sorry. Inside of I'm so sorry. Inside of display hierarchy, what we do is first of all we have this global to determine if it's the Teddy or the humanoid, and we set these parameters accordingly. What we do is inside of here Uh, we have hacks to remove the unwanted nodes for both models. And the idea behind making this converter so hacky is we only export the data that we need so that our engine can be as agnostic as possible. So we don't need to do any, weird hacky stuff inside of the engine. At least that was the plan. So once you've got all the data inside over here for each node, we can simply create a hierarchy node and then set its own index, set its parent's index, and over here you'll see I have a hash map, which basically I am storing the hierarchy. I'm keeping, the node name of the node and its corresponding index. So if I know that my node is not the root node, I know that it's the index of its parent is going to be inside of this hash map, and that's how I look for it. We have, of course, our very handy HDL because this is tools. So this is the vector that I export the skeleton in with the data, and yeah, that's how we export the hierarchy and populate this HDL. Um, Things get slightly more complicated when we go inside of animation, and what we're doing here is okay. So first of all, there's an animation in the Teddy that does nothing. But anyway, so what we're doing is that um, inside of display animation over here, what we need to do is this. I have a keyframe data structure for each one of the humanoids. Honestly, the only difference is the number of bones. But again, this is completely hacky, completely whatever. So we'll just go with it. But you can see that there's a key time, there's a model time, a model type, and accordingly we have the number of bones for each model. So inside of the display animation, based on which model it is, I'll create a data structure, a keyframe of that particular model, and accordingly I'll go inside of here and then just collect the data very, very easily. So you can see that inside of here I supplemented your function with a keyframe. So this is a keyframe data and it accepts keyframes of both models. And then inside of here, we can simply just check which type it is and accordingly do the hacks to remove unwanted nodes. And then come inside here and literally just copy over the data based on what sort of model there is. So the only reason again for the difference is that the number of bones are separate. So this will go all the way to 80. This will stop at 20. And similarly down here. So once we're done with all of this, we go off to our animation exporter. And basically we have two functions. We have a hierarchy chunk and we have an animation chunk. And both times all we do is just use our PA1 system, so the vodka and LIU, and accordingly we create a chunk for the skeleton. This is from this HDL over here. And then in the animation chunk, based on whatever we pass in, we'll write the data of the according HDL for the keyframes and for the Teddy and for the human. So that's what we have there. And then we simply just end up exporting this data. So you can see that inside of display animation, once I get my keyframe, I have it populated, I can immediately just push it back and to the HDL. And similarly, once we're done here, I know that my data for a single animation clip has been populated, so I immediately create that animation chunk. And in the end, when everything is done, all I need to do is just create the hierarchy chunk because the HDL has already been populated, and then we export the data. This will use LIU and end up exporting the data into our SPU file, which I just showed you. So switching over to the viewer, this is the overall architecture here. I have an animation controller that I associate with each each sort of each skeleton. And the idea behind this is you can see that it has a lot of stuff going on here. So basically, an animation controller keeps a list of clips for a particular model. Each clip contains a list of all the frame buckets for its particular animation. And basically what we're doing is using this concept of an animation controller in the chunks that we have, we just start populating the data once we get the SPU files. So going back to the diagram here, this is overall, once we have a controller for the teddy and the human, we need to manage them, which is why we have the animation controller manager. So now, if I go inside of game.cpp, you can see that I just create a teddy controller and a humanoid, and the entire idea here is I have a model type inside of here too. So this way I know which model I'm expecting, and I set things up accordingly. Yeah, this is something that gave me a lot of trouble. Anyway, so once we have this, we can set the number of bones accordingly. So for a teddy, it's 20. For a humanoid, it's 80. And then similarly, based on the type, we're now just easily going to load in the data. So we create a rigid game object root for both models, but after that, we eat the skeleton chunk, and then based on the data we receive, we start creating animation game objects, setting their model types, and then figuring out who their parents are and how to add them. So similarly, I have a function in here called find by anim type and index. So once I know that once I know that I've created something which isn't my root, I need to go and find its parent, and the parent is guaranteed to already have been added. So this function here goes throughout the game object tree and finds that parent accordingly. So once this is done inside of the animation controller, then you can see that these are just special hacks for the teddy. And then for the humanoid, the code is pretty simple without that one extra hack. But once this is done, I'll switch over now to the animation controller manager. And what we're doing here is we have an update, which basically cycles through each controller and calls process animation on it. This one does all the interpolation that we have for our frame buckets and our bones. So it takes over the resultant frame of the active clip of this controller and obviously skips it. And once it's done, it starts interpolating between all the other frames, and accordingly gives the result. When this is done, inside of the game, you can see that I update the controller. Now, once this is done, all the game objects are ready for their new position, orientation, and scale. So we update the game manager. And once that is done, we go in and we say set poses. So once that is done, it comes in here and it calls set animation pose on each controller. And this in here basically just draws the pyramid models at the right moments based on the based on the current position, orientation, and scale. So I think that's about it for the demo, and I think that's about it for the video. The last thing that I wanted to show is just that we have a handle user input, and these are all the controls that I have. This is how I'm speeding up and slowing things down. This was a pretty intense assignment, especially since most of it was done on the plane back home. So, but yeah, I think I've hit all the requirements. I think I went over the controller and the viewer. I'll attach a README to this, and which will have hopefully a lot more descriptions and things like that. But yeah, I think that's it. Yeah, I'll see you next quarter. Have a great spring break. See you.